For Chapter 5, Section 1, we're dealing with graphing quadratic functions, and we have a little word problem today. It says, Dak Prescott wanted to see how high he could throw a football. He initially released the ball traveling at 70 miles per hour. By the way, that's pretty fast for a football. Okay? 7 feet off the ground. What was the maximum height of the ball, and how long did the ball stay in the air before it hit the ground? Make a sketch of the projectile in your journal. So what I want you to understand is, why does it say 7 feet off the ground? Because where would somebody's release point be if you're about 6'3" or 6'4"? It's going to be up higher, right? So what I want you guys to do is, he's releasing the ball up here, which is going to be making him higher than he actually is. So he's going to start out at 7 feet. So we're going to make a little sketch of this drawing. So follow along with me if you would. Make a sketch of this situation. This is the ground. Label the ground as your x-axis. This is height. Label this as your y-axis. I want you to say the x will be equal to this concept of time called seconds, and y will be equal to height, which is feet. If he starts 7 feet off the ground, by the way, this picture is not going to be drawn to scale. Okay? So let's say this is about 7 feet off the ground. He makes a release. He wants it to go what? Super high. So he's launching it as high as he can up into the air until it reaches its maximum height. I'll put a dot right here. I'm going to write the word maximum. And then that football is going to come back down to the ground. Okay? Now, this is known as the max or maximum. What word in this picture do you think that represents? By the way, what shape does this look like? A parabola. Very good. So this shape right here, all right, this function that's dealing with quadratic functions is indeed a parabola. Okay? So this shape right here that we're drawing, this function is known as a parabola. All right? The maximum height is what's referred to as its vertex. So we're going to find the vertex. By the way, the vertex will have an x-coordinate and a y-coordinate. And our maximum height will be whatever the y value is. Whatever the y values will be our maximum height. What will the x value be? That will be the time in seconds it took to get there. Something that's special about all parabolas, all right, is it has a line that passes perfectly straight down through the vertex that splits it perfectly in half. In fact, it actually makes both sides what's known as symmetrical across each other. Does anybody know what this vertical line that passes through the vertex is called? It is a line of symmetry, but we refer to it as the axis of symmetry. It is the same thing, but remember, there's lots of things that have lines of symmetry. In a parabola, we refer to it as the axis of symmetry. All right? So this is your picture. Now, as we scan here, we have some certain words we probably need to figure out what we're going to do. Do you think we're going to use the 70 miles per hour? Definitely. We're going to use the 7 feet off the ground? Absolutely. Those are two numbers we're going to be needing. Okay, one of them deals with a speed or a velocity. Okay? Yeah. What's the difference between speed and velocity? Velocity has a certain direction to it.
Velocity, speed, direction.
Yeah, exactly. So right now, I'm going to scroll down. You guys are going to look at some more information. Hopefully you have this going down right here. I want you guys right now to write all of this information. We've made a sketch. I want you to write all of these down. If you're watching the video, it might be a good time to pause. All right, right now we're going to use this formula right here. Okay? So I'm going to highlight different things. This right here, h of t, this is in function notation. This refers to as time. Basically, height is a function of time. Goes right there. That's our height in feet. That's what we're going to be finding. What's the maximum height? T represents seconds. You'll notice we have a t variable here and a t variable right there. This one's kind of tricky. This V with a subscript of O represents the initial velocity in feet per second. We're going to find the feet per second, plug it in there. And the easiest one that we have is this H subscript O, which is the initial height. And we already know that. What's the initial height going to be? What's the initial launch? 7 feet. So this right here, that's going to be 7 feet right here. Okay? But he threw it at not feet per second. I didn't give you that right. What did I give you? I gave you 70 miles per hour. So we're going to do a little dimensional analysis right here. I want you to write in your journal 70 miles over 1 hour. Now my daughter, who's in the 6th grade, did a little bit of conversion last night. We did some homework, okay? And one of her things that she needed to know to do her homework is she needed to know that 5,280 feet was equal to, that's right, 1 mile. So she had to use that, okay? Right now she's doing distance conversions, okay? However, we also need to do time conversions, and we also need to know that 1 hour is equal to, wow, how many seconds? Close. 3,600 seconds, okay? So we need to change things from what? Miles per hour to feet per second. So we need to get rid of the miles, and we need to get rid of the hours. First thing I'm going to do is I'm going to get rid of the miles, because I know that 1 mile is equal to 5,280 feet. And you'll notice that if we do this conversion, what unit of measure is going to cancel out? The miles are going to cancel out, and then we're going to be left with what? We're going to be left with feet per hour. So this answer would be how many feet you would go in an hour. Okay? Well, we need to go from miles per hour to feet per second. So we need to get rid of this what? 1 hour. So right here, I'm going to write 1 hour up top. And how many seconds am I going to make it equal to? 3,600 seconds. And now these units called an hour will cancel out, just like the miles will cancel out. And what are the only units we have of measurement? We have a feet over a second. All right? So what you guys could do in the graphing calculator is you could take 70, which is 70 over 1. You could multiply it by 5,280 and simply divide it by 3,600. Okay? So if you do that in the graphing calculator, all you have to do is take 70 times 5,280 divided by 3,600. When you're multiplying fractions, remember it's numerator times all the numbers in the numerator divided by the denominator. And what do we get? We get 102.6 repeating, which means our initial velocity, I'm just going to write this a little bit more condensed, 102.6 with a line over it, and write that as feet per second. By the way, the length of our room here is about 30 feet. That's the length. So imagine a ball traveling over 3 lengths of this room in 1 second. That's how fast that ball's going. Okay? Pretty fast. Okay? All right, so now that we have that, let's write out our formula. Here we go. I want you guys to write this down in your journal. H of t equals negative 16 t squared plus 102 point. Right now I'm just going to write 6 repeating. I'm going to eventually in the calculator type in a few 6's. Times t plus 7. So here's our formulator. Sorry, here's our formula. All right, I'm going to take this formula, I'm going to change it into terms of x and y. So h of t, which is your feet, is going to represent your y value. I'm going to write negative 16. Instead of a t squared, I'm going to put an x squared, knowing that t just represents time, so x now represents time in seconds. Plus 102.6 repeating times x plus a 7. So this is the formula I'm going to use to type in, the equation I'm going to type in to my graphing calculator. If you haven't written it down, that's okay. You'll see me type it in the calculator. We have y equals negative 16 x squared, oh, not x squared, plus 102 point, I'm just going to do a few sixes here. I'll do more than 3 so I don't freak anybody out. X plus 7. So there's your equation typed into the graphing calculator. Now, I want you to hit the second button and the graph button, and let's take a look at this table. You guys see right here, at 0 seconds, right now the ball is what? At 7 feet high. After 1 second, it goes up to close to 94 feet. 2 seconds, up here. What does it look like our maximum height is? 171, right? Because it starts to go down after that. But actually, that's not going to end up being our exact answer. So right now, looking at this table, I want you to hit the graph button. Let's take a look at our graph. What do you notice about our graph right here in the graphing calculator? It's too small. So I want us to learn how to change the window. So follow me. Here we go. Hit the window button, everybody. I want you to make your time, your x values start at 0, and we'll keep the time ending at 10. Your x scale will still be 1. Every single tick mark on the x-axis will be 1 second. The y minimum, let's start at 0, thinking 0 is 0 feet off the ground. Okay? And the y maximum, let's put it all the way up to 200. Because we know it's not going to give up 200 feet. Okay? And the y scale, let's change it to 20 so we don't have 200 little tick marks going all the way up the left side. Okay? So once we change that to 20, hit the graph, and now we see a better picture of the football starting out right here at a 7, going up to its maximum height, and then going back down to the ground. Okay? So does everybody agree that the maximum height is somewhere up in here? Right? Okay, now, 2 ways you can kind of figure this out. If you want to hit the trace button, you can take this little cursor, and you can actually move it up to the highest point if you wanted to kind of get an estimate of what that maximum height is. What's about the highest point that you guys can get? That's about the highest I can get with the trace. Okay? That right there is an estimate. It's not the exact answer, but it is an estimate. Okay? We're going to show you right now how to get the exact answer just using the graphing calculator. It's second, trace, and which number do you think I'm going to choose to find the maximum height? Right, 4. Now, this is where it gets a little tricky. You see the word left bound? We have to establish what's known as a left boundary, everybody. We have to establish a left boundary and a right boundary. That's what we have to establish on the graphing calculator. So let me show you how to do that. All right? What we're going to do is we're going to move the cursor to the left of the maximum. Once you've moved the cursor to the left of the maximum, we're going to press Enter, and that establishes the left boundary. Now it's asking us to find the right boundary. So you're going to go to the right side of the maximum. So now that, notice how my cursor is starting to go down. That lets me know I've gone past the maximum. Now I know that the maximum has to be between those two x values, those two vertical lines. Okay? Now that you've done that, you can press Enter. And now it actually gives you the exact, well, maybe it's not exact, but the approximate value of that, the most exact answer that we're going to get. So what does this mean? We're at a 3.21, comma, 171.69. What does the 3.21 represent? That's the seconds. That's how long it took. That's how long it took to get to the maximum height of 171.69 feet. Now this answers part of our question. We're running out of time in the video, so I'm just going to end with this part. All right? This is how you can find the maximum if you have a graphing calculator and you change your window so that you can see your projectile, your parabola. Okay? We're going to do it by hand in the next video.